In 1957, the Soviet Union launched the world's first satellite into space, Sputnik 1. It was a small, uncrewed sphere with a diameter of only 58 centimeters, yet it weighed 83 kilograms. This event marked the beginning of the space age and humanity's journey beyond Earth. And at the heart of this remarkable achievement was an innovative spacecraft that enabled us to reach for the stars. Since then, countless spacecraft have been sent into orbit around our planet. However, what is a space orbiter? What makes it different from other spacecraft? In this video, we will explore the fascinating world of orbital spacecraft and how they work to enable us to unlock the mysteries of the universe. But before we do so, please subscribe to the channel and hit the bell icon to get notified of the release of our latest videos. Now let's take a look at what a space orbiter is. A space orbiter is a type of spacecraft that is designed to travel into orbit around a celestial body such as Earth, Mars, or any other planet. Orbiters are typically unmanned and are used for a variety of scientific, navigational, and reconnaissance purposes. They are an essential component of many space missions and have enabled us to learn more about the universe than ever before. The main function of an orbital spacecraft is to perform scientific experiments and observations from a vantage point above the surface of a planet. By placing a spacecraft in orbit, scientists can study the planet's atmosphere, surface, and magnetic fields without the interference of Earth's own atmosphere and radiation. For example, the Hubble Space Telescope, which has been orbiting Earth since 1990, has revolutionized our understanding of the universe by capturing stunning images of distant galaxies, nebulae, and other celestial objects. Another important function of orbital spacecraft is to serve as communication satellites. These satellites are equipped with powerful antennas that can relay signals over long distances, enabling communication between spacecraft and ground stations. They are also used for broadcasting television and radio signals, as well as for providing internet access to remote areas. For example, the Globalstar satellite constellation provides global satellite communications for maritime and land-based users. Its 48 low Earth orbit satellites are used for mobile voice, broadband data, and short message applications. Orbital spacecraft are also used for Earth observation and environmental monitoring. Satellites equipped with high-resolution cameras can monitor changes in land use, track the movement of vehicles, and monitor weather patterns. They are also used to collect data on climate change, such as rising sea levels and changes in temperature. For example, the European Space Agency's Sentinel satellites are used to monitor the Earth's land and oceans for the European Union's Copernicus Environmental Monitoring Program. In addition to their scientific and technological applications, orbital spacecraft also have significant military and intelligence applications. Reconnaissance satellites are used to gather information on military targets and enemy activities, while spy satellites are used to conduct espionage operations. For example, the United States' Keyhole and Corona programs of the 1960s deployed a series of reconnaissance satellites to photograph targets in the Soviet Union and China. One of the main advantages of using orbital spacecraft is their ability to reach places that would otherwise be inaccessible to humans. By launching a spacecraft into orbit, we can explore regions of space that are too far away or too hostile for human beings to survive. For example, the Voyager 1 and 2 probes have traveled to the outer reaches of the solar system, sending back invaluable data and images of the planets Neptune and Pluto. Another advantage of orbital spacecraft is their endurance. Unlike human beings, spacecraft are not limited by the need to carry life support systems or by the effects of radiation and cosmic rays. As a result, they can remain in space for extended periods of time, conducting long-term experiments and observations. For example, the Voyager 1 probe has been operating for over 45 years and continues to send back data on its journey out of the solar system. Another challenge associated with orbital spacecraft is the risk of space debris. As more and more spacecraft are launched into orbit, the risk of collisions with debris increases. This debris can pose a serious hazard to spacecraft and astronauts, and it requires careful monitoring and avoidance. To mitigate these risks, several organizations, including the European Space Agency and the United Nations, have developed guidelines and protocols for the safe and sustainable use of outer space. These measures aim to minimize the risk of collisions and to ensure that space debris is properly disposed of. As technology continues to advance, we can expect to see new and innovative uses for orbital spacecraft. For example, the development of reusable rockets has made it more cost-effective to launch spacecraft into orbit, opening up new possibilities for commercial and scientific missions. Additionally, the growing interest in space tourism and the use of orbital spacecraft for transportation and logistics could further expand the role of spacecraft in our everyday lives. There are various types of orbital spacecraft, each designed for a specific purpose. Let's look at some of them. First, we have communication satellites, which are used to relay signals over long distances. These satellites are typically positioned in geostationary orbit, which means they remain above the same point on Earth's surface as the planet rotates. This allows the satellites to provide continuous coverage of a specific region, making them ideal for communication applications. Another type of orbital spacecraft is navigation satellites. These satellites are used to provide positioning and navigation services to aircraft, ships, and other vehicles. The most well-known navigation satellite system is the Global Positioning System, or GPS, which is operated by the United States. Scientific research satellites are used to conduct scientific experiments and observations from space. These satellites are often equipped with telescopes, spectrometers, and other instruments that allow them to study the universe in detail. Some examples of scientific research satellites include the Hubble Space Telescope and the James Webb Space Telescope. Earth observation satellites are used to monitor changes on the surface of the Earth. These satellites are typically equipped with high-resolution cameras that allow them to capture detailed images of the Earth's surface. Earth observation satellites are used for a variety of applications, including weather forecasting, environmental monitoring, and urban planning. Spacecraft are typically launched into orbit using rockets. A rocket is a vehicle that uses thrust to move through space. To launch a spacecraft into orbit, the rocket must generate enough thrust to overcome the gravitational pull of the planet. Once the rocket has reached the desired altitude and velocity, the spacecraft separates from the rocket and continues on its own trajectory around the planet. In conclusion, orbital spacecraft have revolutionized our ability to explore and understand the universe. These versatile vehicles have enabled us to study distant galaxies, monitor changes on Earth's surface, and communicate across vast distances. Despite the challenges associated with their use, the benefits of orbital spacecraft far outweigh the costs. As technology continues to advance, we can expect to see new and innovative uses for these remarkable machines that will allow us to unlock the mysteries of the cosmos like never before.